I'm going to take a minute here to talk again about the dimensions of NEMA 17 motors. Depending on where you get your steppers, there's a few alternatives for that. You're going to notice that NEMA 17 motors are not all the same size. The spec specifies, what size the face is and the shaft and these holes and so forth. But there's a couple things you have to look out for. One is you have to make sure that your mounting holes are actually M3s or number 4. It could be either way. The other thing is that since they come in different torques, these are both NEMA 17 motors. You notice they are radically different depths, almost twice as tall there. And what this means, for most of these, for the X and Y, it doesn't matter because they're sitting on the outside of the machine. For the Z-axis, however, it's an issue. So, since we're going to be actually gluing, epoxying, in fact, the Z motor to the back of the X-axis sled here, you're going to notice if I hold this here, the bottom of this motor is actually in line with the motor shaft. So there's absolutely no room for the lead screw to cross across here. It's we put the lead screw in this scrap of lead screw in here. You're going to notice there's actually no room for it. So in order for there to be room for the lead screw and for the coupler, this higher torque motor that it measures almost 2 inches, over 1 3/4 inches deep, you've got to do something about that. And whereas this is a much shallower motor, of course, you epoxy that in there, there's scads room. So really, about the most that you can get away with is just about 1.5 inches of height on your NEMA 17 motor. So you got to make sure in the dimensions of the motor that you're ordering, because the suppliers change, the availability changes, and the prices change radically from month to month. Need to make sure this dimension on at least one of your motors isn't more than 1.5 inches. And while you're at it, make sure that you've got the proper mounting screws. They're usually M3s, sometimes they're number 4s, and you have to make sure. We're going to talk about putting the spindle bearings into the lower part of the Z stage here, the spindle stage, I guess we call it. And you remember back when we glued these two together, we put the sleeve in here, this 5/8 inch internal diameter sleeve. And that is what these two bearings, which are 1/4 inch on the inside for the 1/4 inch shaft and 5/8 on the outside, that's what they're going to ride. There's one riding at the top and one riding at the bottom. And the 1/4 inch shaft, of course, is going to go in on the inside. You may wonder why it's built like this. It's because, why not just stick a Dremel on there? The reason is that Dremels actually have pretty bad run out, as it's called. What that means is as the Dremel's spinning, the bit is actually oscillating, around in a circle. It's wobbling. Whereas with this, pretty beefy 1/4 inch shaft and these two bearings, you get very, very little run out. You actually get a very, very precise spin that is also quite rugged to resist all of the lateral forces it's being subjected to. Even though those aren't terribly huge, this component should actually last quite a while. So you can use Loctite to put this in. You can also use a high quality epoxy. It really doesn't matter. The epoxy, it might be a little more difficult to work with, but it really depends on your technique. Also, if you're going to choose to get your shaft from, say, Servo City, which is a little easier on shipping, you may find that you cannot get the actual exact length you need. So we're going to end up cutting this shaft down. But right now what we're going to use it for is actually as a guide to make sure that the two bearings are completely aligned. And note that there is really no difference between the inside diameter of the bearing and the shaft itself. It is a really tight fit. Likewise, this 5/8 and this internal 5/8 here, very, very close. You have to have things really aligned very well to go together. So the way I like to do this is to have one bearing on the shaft, put the shaft through, and then put the other bearing on the other end. And again, you have to align it very carefully and wiggle it, very gently, and then it'll go on the shaft. So you want to basically set it up like that while we get the epoxy, or if you're going to use Loctite, while we get that ready. Alright, so now that we have this epoxy, and again, you want a good quality, long setting epoxy like JB Weld that's really going to hold it in there, because there is going to be a lot of vibration and a lot of lateral forces on this, and so you don't want something that's going to pop free. One thing you don't want to do, you don't want to go putting epoxy on the inside of the spindle sleeve, because then as you push the bearing in, you're going to be kind of like bulldozing it ahead of it. And so then you could have enough that it might actually like be able to creep over the shield and get all the way into the middle of the bearing and epoxy the bearing to the shaft. That would not be cool. So what we're going to do is we're going to put a little tiny bit of it all the way around the bearing itself and then push it in, and that will hold it. So we're just going to hold it here really gently and just kind of rotate it around. Always have a piece of paper towel with you so that you can wipe up any smudge. You really do not need much. This does not take a lot at all. Okay, but you do want to get it all the way around the bearing. Just a little bit, not a lot, because you don't want this to get on everything. You just want it to get on where it needs to go. Clean off your thumb. And you just want to come in here and very carefully align it. You can use the other side here, like, hold on, like so. And then just push this in. Wiggle, wiggle, wiggle. And just get it positioned just a little bit. It can be sticking out at the bottom. We'll do a final adjustment. And then hold it there while we slide the other bearing up into place. And do the same thing. Just gonna put it on with a little bit of epoxy all the way around it. Again, don't need a lot, but it needs to go all the way around. Get a little on the wood, that's no big deal, just clean that off. Okay, so we got epoxy all the way around. And we're going to do the same thing. Clean off our fingers. Cleanliness is next to bearingness. Support it on the other side here, and again, we're just going to wiggle, 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 wiggle. Get that bearing to slide right into the sleeve. And that's it. So now they're both positioned, and you notice how the shaft is serving as an alignment tool to make sure that those bearings are completely in line. Make sure there's nothing on the shaft. That shaft's fine. And then, now that they're sitting in there, we're going to take something a little more precise, like say an Allen wrench, and we're just going to come in here and just make sure that the bearing, maybe a finger, is just flush with that end. And we're going to make sure the bearing is flush. Hold it on this side. Make sure that the bearing is flush on this side. So the bearing is flush with both sides. Make sure there's no blobs of anything. Here. And take a look and see that the epoxy is only on the outside edge of the bearing. It is not anywhere on the shield or, God forbid, anywhere on the shaft. It's only on the outside. Let's just make sure there's no excess. So that's basically it. Now I'm just going to leave that and put a warning sign on it so nobody comes in here and messes with it. And that those bearings are going to be epoxied in place. And then afterwards, of course, once they're completely hard, I'll just slide that shaft out, and then we can proceed to mount the spindle. But for now, it can just sit here and harden up. We're going to discuss and describe a couple of different options for coupling the NEMA 17 motors for the X, Y, and Z axes to your various pieces of lead screw. Now, in the original Mantis design, it was the process used was actually using a lathe to bore out the end of the lead screw to 5mm and then Loctiting it onto this 5mm shaft. That is a little difficult for a lot of people to accomplish, and the rest of it is so easily built that we wanted to find some alternatives. So the first one we're going to go to, which is the quickest and dirtiest, sort of lowest end of it, is to use a piece of 3-inch dowel, which of course will match the diameter of the 3-inch lead screw. And we're going to bore out on a on your drill press that you've been using for everything else, a 5mm hole, which is just a hair over 3/16. And so you can drill a 3/16 hole and then just route it out or sand it out a little bit just so it will barely slide on here. The nice thing about this system is that it's not going to require that the hole be absolutely concentric, which is really difficult to do. But because the axes are actually held in place and aligned by these rods, the fact that the lead screw, the end of the lead screw with the motor may be wobbling back and forth a little tiny bit, shouldn't really affect the axis at all. So I'm going to get the epoxy, and I'm just going to epoxy this 3/8 inch adapter essentially. It's got a 5mm hole in it now, and I'm going to epoxy it onto the end of the motor shaft. And once that is hardened, or while that's hardening up, I'm going to, and this is about 3/4 of an inch long, this little piece, and doweling of course is so cheap that you can make a whole bunch of these and just keep working on them until you find one that looks reasonable for you and is the best centered. And I'm going to take about a 3/4 inch piece of the lead screw, and I'm going to epoxy it inside a piece of this tubing. Now this is just standard vinyl tubing with a 7/16 inch outside diameter and a 5/16 inch inside diameter. So in other words, it's just a little hair too small to go over either the doweling or the lead screw. So it's going to be a force fit, and we're going to butt these two up against each other, and then the vinyl will bridge the gap and thus unite these two. And it should not have any rotational slop at all. It may have a little bit of flex, which is actually fine, but no rotational slop. This technique of using vinyl to butt up two shafts and join them was actually used in a lot of the early rep strap designs for some of the early rep wrap models when people were just getting started with 3D printing. So I'm going to epoxy this 3/4 inch piece of 3/8 inch wooden dowel that's been drilled out to 5mm, and while that's hardening up, I'm going to take an 1.5 inch piece of the tubing, 5/16 inner diameter vinyl tubing, and I'm going to epoxy this lead screw about halfway down it, so about 3/4 of an inch of that. And then after I've already shown you epoxying a bunch of times, I doubt I have to show you that again. So I'm going to get that done, and then I'm going to show you the next coupling option. This is the other coupling option that we're going to go over. 3D printers have become ubiquitous enough in the DIY and hackerspace scene that we thought we would put in a printed coupler option as well as the completely hand-built wood plug and vinyl tubing option. So this is the STL file that you can download from this instructional site, and one side of it has a 3/8 inch bore, which with a little persuading will accept this 3/8 inch lead screw, and the other side has what is mostly a 5mm hole with a rectangular slot on one edge of it, and then a 3mm hole going through the side. And the way you set that up is with your standard M3 nut goes down into the slot, and then an M3 set screw, I believe this one is 3 or 4mm long, goes in through the side hole and engages in the threads. So once you have that in, without it of course the motor shaft just slides right in that hole. That flat occupies part of the space, so we're going to have to grind a flat on one side of the motor shaft to engage the flat on the grub screw, and then it will be tightened down with the set screw. And then, so that will be the removable portion when we need to take the mill apart later. And then this side that has the 3/8 inch lead screw, that side's going to be epoxied. So just going to get the Dremel out here, safety glasses. And I'm just going to do this in a completely ad hoc way. Just hand grinding it, because again, it's not absolutely essential that we have it completely precise. Just want to get the depth correct. It's just half of the coupler, so I can actually put it on one of my other couplers and go right to max depth here. And I want to shut it back to about there. There we go. So that'll be enough depth on that side. And I'm just going to manually grind it with the Dremel. So move my parts out of the way. And I'll just grind it bit by bit and then test it occasionally until I find the size that I want to use. And you can start to see get a flat on there. Of course, you don't want to go testing it when it's actually hot, because you'll just melt the ABS coupler, and that wouldn't work. But I can see the flat on there. Probably is not enough yet. I'm going to let that cool and test it. Then I'll just keep on grinding it until it fits. You can alternatively, you could also grip this with a clamp here and then use a file to do it. That would just take a while. But if you don't have a Dremel, you can also use a file to put that flat on there. So we're back looking at the wooden adapter version of the coupling system. This has this wooden coupler, which is, I said it was 3/8 by 3/4. It's actually 3/8 diameter by about ½ an inch long, but the exact dimensions don't matter too much. Has been epoxied onto the shaft there, and I put some epoxy on the 3/8 inch lead screw, and I forced it into half of this 1½ inch piece of the tubing. So when we actually assemble this inside the Mantis, we're just going to put a little epoxy on the inside of the tubing, and we're just going to force it down over the slightly oversized hub. It's a 5/16 inch inside diameter tubing, 3/8 inch coupler, so it's going to be a force fit. And then when it comes time, if you ever need to disassemble it, the disassembly option is to take a razor and slide it right between the two halves and cut the vinyl, and then you can easily strip the vinyl off of both pieces and disassemble the axis. So that is the way that one will go together. And we have now also finished grinding the other option. So we've ground a flat onto this motor shaft for about, I believe it's about ½ an inch I measured. And we've epoxied the other half of the coupler onto this lead screw. And so this flat on the shaft now fits down this 5mm hole, and the flat goes right past the grub screw, or the grub nut, and the set screw, of course, is going to tighten down on the shaft. And that'll be that axis. And obviously, to disassemble that one, this side is the permanent side. This is the side that you can disassemble by loosening the set screw and then just pulling it off. So take that back off, and then we are going to show how these two different couplers are used on the two different axes. You, of course, will use whichever option you choose to go with. We're just using both options in this build on two different axes as a demonstration. We are about to assemble the X-axis. We used the longer lead screw for the printed coupler option. It's now epoxied to this end of the lead screw, and so that's the one for the X-axis. So we have our motor that has the flat ground here to mate with the grub nut in there. And we've got our mounting holes, which you remember we countersunk. We've got our 4 mounting screws there, which for this particular motor are M3s. And I've also taken one of those lead screw nuts, the Delrin lead screw nuts that you remember us making, and have screwed it down to approximately the right point, about halfway down the shaft, and it's going to go right across, pardon me, it's going to end up laying in about the middle of the X carriage like that. And we're going to epoxy it into place. And of course the motor is going to be mounted here and bolted in place, and then it's going to mate with the coupler, and then I'll show you a little bit of alignment that goes on when we actually do the gluing. But this is the way it's actually going to go together. You'll notice, if actually we have to move this particular camera, you'll notice that I actually have this assembly, the legs of it are hanging off the back edge here. That's so that the upright can be flat on the table surface. So that's probably good enough. Okay, so I'm just going to screw these screws in here and get everything lined up, and then we're going to go back and show you how it actually goes in. Alright, so I went ahead and I mounted the motor here. Notice I ran the wires towards what is actually the rear of the mill, because we're probably going to end up mounting whatever electronics we use on the rear, so you don't want to have to drag your cable all over the place. It's not too hard to rotate it, obviously, into the right position if you mess that up. So it's securely mounted with its 4 screws, and we've got our lead screw on here at about the right point, and our coupler, of course, is securely epoxied onto the shaft. Nuts in there, set screw mating with the nut, so we're all set. Last thing we want to do is, since we are going to epoxy this Delrin AF lead screw onto the back of this X carriage, and we've been handling it, and this is a greasy lead screw, we want to make sure we don't have grease all over this thing, so we're just going to give the outside of the lead screw nut a quick wipe off with either acetone or denatured alcohol, something that will just take that grease off if it happens to be there. Grease and epoxy don't really bond awfully well. There we go. So that's now clean, and this is acetone. It dries quick. There's really nothing down here. I'm just gonna give that a wipe anyway. Okay, so got this set up. I'm gonna slide it in through this hole here. Align it with the flat on the motor, and slide that on the motor shaft there. Have my Allen wrench ready. Just going to tighten that puppy down. And more time. Make sure that's good and tight. It's on there. Now what we want to do is screw the lead screw out to the middle here. Now we talked about how the lead screw hole, the hole in the lead screw nut, did not actually need to be completely concentric, and that's fine. So we can rotate the whole shaft here to find at what point on the lead screw we're going to have here we go. We're going to have this lead screw touching the X carriage like we want it to, because the hole is lopsided. We just rotate the whole assembly until it actually touches. And we want to make sure that this is more or less aligned, and that this shaft here is pretty much in the center of this hole. And once we've got that, we have our epoxy ready to mix over here. You can see I've already done all these other mixings over here of it. And this is actually the 5-minute or quicker version of JB Weld. And we're just going to get that underneath this crack of the lead screw over here. And we want to turn that under so it drags the epoxy underneath a little bit. And we want to get it on the other side of the lead screw. Obviously you want to keep it in the middle of the lead screw nut and not get any on the actual lead screw threads, because that would be a bad idea. So we've got it on both sides here. Let's put the excess on this side because it had a little less. Now in the original assembly, there was actually another piece where we took a 1/2 inch plumbing strap coupler and it went over the outside of the lead screw nut to help hold it in place. I experimentally left that off of my first build, and using this JB Weld to hold the Delrin AF lead screw nut in place, it has not moved and it's completely rigid. I also think that the absence of that coupler is going to help substantially when, say, you get some excessive wear on your lead screw nut and you want to replace it later. You can just go in here with a Dremel and cut it out and you won't have that strap in the way. So this shaft over here is centered in this hole, and this is in contact with the back of the X carriage. The coupler is firmly attached to the motor, and so that's the X-axis. It's epoxied together and screwed together, and we're going to sit here and let it harden up. We're going to use the Y-axis, and of course this is the Y-axis flipped upside down. We're looking at the bottom of it now. We're going to use the Y-axis to demonstrate the other coupling option, the real quick and dirty one, using the 3/8 inch wooden adapter epoxy to the motor shaft and this piece of 5/16 inch inside diameter vinyl tubing that has been epoxied to the end of this lead screw. And we're going to mount the motor and force with a little bit of epoxy on the adapter. We're going to force that up inside the vinyl tubing up until it mates butt to butt with the lead screw like that inside the tubing. And we're going to put our lead screw nut, just as we did with the X-axis, we're going to put it on the shaft and move it down to, you know, about the middle of the underside of the Y carriage here, and we're going to epoxy it in place exactly as he did with the X axis lead screw nut. So just going to mount the motor, and then we're just going to show you how these are going to force fit together, stretching this vinyl and epoxying it in place underneath here. Alright, so I've now epoxied this adapter up into the vinyl tubing, which you really didn't need to see. That's pretty easy. And I've taken acetone as before and cleaned off this Delrin lead screw nut to make sure there's none of this grease from the lead screw all over it. And you'll see this thing right here. What this is for is, since I've got the back panel laying off the rear of the table here so that I can work flat, once I put this motor on here, all of that weight wants to flip it. So I've taken this big storage box, which is a substantial amount of weight, and I've just rested it on the front lip just so it doesn't flip up. So I'm just going to insert the motor from the rear hole and press it into place. And of course I'm just going to take my 4 mounting screws, mount the motor permanently, and then there's a little bit of axial play in this lead screw, which is just fine as long as there's no rotational slop again. And so, as before, I'm just going to rotate around this Delrin lead screw nut, looking for where it actually touches nice and flush. Again, it's not completely concentric, which is to our advantage. And then I'm just going to epoxy it right in the middle between the 2 guide rails, as I did on the Z-axis. We're going to attach the Z-axis motor to the back of the X stage here. And remember, I said earlier that because you are limited in the amount of space you have here, you have to make sure that the height of your Z-axis motor is small enough that it'll actually fit in there. As the torque of these NEMA 17 motors goes up, they tend to become longer and longer. So make sure that you've got one that will actually fit in that spot there. So it's actually just epoxied in place, and you want to put the wires out to one side or the other, not to the rear, because you're going to have to put a C-clamp on here to hold it. So you actually want to run it out to the side. Left or right really doesn't matter. After putting the epoxy on there and a thin film, we're just going to position it in place. You don't have to worry about getting it too level right now. Push it down so that you'll squeeze that film out and it'll stop skating around on you. Okay. And then get your C-clamp And this is when you have to start picking it up. Make sure you've got enough room to start with. Get it close to where you want it. Okay. Then pick up the whole assembly. A little more room, a little more room. And that should be just about enough. And then just tighten it down. Finger tight at first. Very little, because you're going to have to adjust this. Once you've got it tight to where it will sit where you want it to be, you have to start wiggling it around. Get it level, get it centered, and again, just by eye is adequate for this task. And then just tighten it up a little more. Make sure that it did not skate around while you were tightening it. Tighten it a little more. Make sure it's not, it now feels nice and rigid. It is still level compared to the Z-rail, and it's still centered compared to that center hole. So we can now actually turn it on its side and it can harden up.